Okay, here we are in section 3, area of pyramids and cones, page 79 and 80 in your spiral. Okay, on your notes page. Okay. Theorem 12.4, surface a regular pyramid. If it's a pyramid, just so you know, is that the sides are going to be triangles. That indicates that it's a pyramid if it's triangles. So the formula for surface area is capital B, which is the area of the base, and then it's 1/2 of PL, where P is the perimeter and L is the slanted height. The slanted height is the side's height, the lateral height. On 12.5, surface area of a right cone. Cone, the base is a circle, and there's no triangles on the sides. This is still the slanted height, and that's the radius. The formula is B plus 1/2 the circumference times the lateral height, which you could change that to the circle formula, plus pi r L will work for the surface area of a cone formula. C is the circumference, R is the radius, L is the slanted height, and B is the base. For example 1, there's an important word here. They're wanting you to find the area of each lateral face. That vocabulary that they're saying right there means that they're wanting you to find one of the triangles. The area of one triangle. So instead of using these formulas up above, for this one, you're only going to do the area of a triangle, which is BH divided by 2. So if I look at the triangle that they give me, they tell me the B, which is 90. And then I need to multiply it times the height, which is the slanted height of your triangle that they have over here inside, but it's not given to me at all. So I have to visualize that they give me this side and the bottom edge of a right triangle that exists right there in the middle. I'm going to color it in so you can try to see the actual right triangle that actually exists, because they tell me that this leg down here is 45 and the height is 97, and I need that information because that's a right triangle. So I can use Pythagorean theorem, a squared plus b squared equals c squared, to actually find this slanted height. So I'm going to do 97 squared plus 45 squared will be my c side. Okay, if I do 97 squared times 45 squared, I get 11,434. And that is equal to my c squared, so c will be the square root of that. So this number here is actually my slanted height, so that's what will go in this slot here, is 106.929, and on and on and on. I'm going to use the number that's in my calculator. I'm going to take that number and multiply it times 90 and then divide it by 2 to come up with my area of my triangle, which is 4,811.8 centimeters squared. If I go with example 2, they now want to know the surface area of the pyramid. The formula for surface pyramid is base plus 1/2 PL. So that's what I'm going to write down here. Base plus PL divided by 2 will be my surface area. Now, the B is a hexagon. So the formula for a hexagon, if you remember, was PA divided by 2, where P is my perimeter, The perimeter will be 8 times the number of sides, which is 6, so that's going to be a 48. The apothem is given to me of 4 square roots of 3, and then I'm going to divide it by 2, and that'll give me my B. Okay, so I put in 48 times 4 square roots of 3, and then I'm going to take that and divide by 2 to see that my base is that value. So that is my B. If I bring it over here back to my formula, that means I'll have 166.2768775 plus my perimeter, which we said was 48, times my lateral, that if I look at my picture, the lateral is the L. So that's 18 divided by 2. So I'm going to take that value and add to it 48 times 18 and divide it by 2. And that will give me my area of 598.3 inches squared. Alright, on example 3 is the cone, which is, I think, the easiest shape that we have. The pyramid can be rather difficult based on what shape the base is. On the cone, I just wrote out the actual formula that we're going to use instead of the modified one. We realize that R is the radius is 3 and the 5 is my slanted height, so I'm going to plug in those two values into my formula. Okay, so if I just type it in my calculator, like so, and I push enter, I'll get my answer, 75.4. Okay. I want you to work both 1 and 2 independent practices, and then I'll come back here in about 5 or 6 minutes and I'll go through those problems to see if you got them correct. Okay. On A, it says the area of each lateral face, so that means it's just a triangle. So that would be BH divided by 2. So the B is 20, the H is 30, so that should be 20 times 30 over 2, which would be 600 over 2, which is 300 millimeters squared. Should be your answer for A. On B, I went back to capital B plus PL divided by 2. The area of the base is 20 times 20. So that should be 20 times 20 plus the perimeter will be 20 times 4, which will be 80, times the lateral, which is 30 all over 2. So 20 times 20 is 400 plus 80 times 30 is 2400. And divide by 2, so that would be 400 plus 1200, which equals 1600 millimeters squared would be the total surface area of that pyramid. On number 2, I'd use the cone formula, which is pi r squared plus pi rl, where 6 is my r and 10 is the l. So that means this would be pi times 6 squared plus pi times 6 times 10. And there I have to use my calculator. So that would be squared plus pi times 6 times 10. Okay, if I got typed in, that would be 301.59. And that would be feet squared would be your surface area, because it did say 2 decimal places. Alright, if you got those correct, then you're probably going to do okay on the prisms, the pyramids and the cones. The difficult one is going to be the pyramid, based on what they give you. They may give you hexagons for bases, or pentagons, or heptagons. Depending on what base they give you on the pyramid, it'll be how difficult your problems are. But if you got those correct, you're probably doing okay.